All right, in this section, this is day 2. We're going to look at scalar multiplication, vector addition, and finding unit vectors. Okay, scalar multiplication. The most important thing to remember is that a scalar is a number and not a vector. So what you're doing is you're multiplying an actual number times a vector. So if I were trying to find 3 times vector u, I would write it out like this. And then just multiply 3 times both components. So this would be -3, 9. And then 5v would be 5 times the vector. And so this would be the vector 20, 35. And you can see that it increases the magnitude of the vector. Multiplying times 3 is going to increase the magnitude of the vector. Vector addition can be represented graphically and numerically. And I've drawn a couple of graphs here. They're not super great, but you can kind of see that the point that I want to do, or what I want to do here, is I want to add u plus v. I want to add u plus v together, the two vectors. So this one method is called the head-to-tail method, whereby you put the tail of one vector on the head, and then when you want the actual addition, you then connect from the origin, the head of one, tail of one, whatever, you're connecting them. Anyway, head to tail method. And then this vector right here, this u plus v vector, is the resultant vector. The resultant. This is an important term. Vector sum, the sum of the two vectors is the resultant vector. The other method, the one that they outline in your book, is called the parallelogram method. And that's where, here's my u and my v, and they're both in standard form there at the origin. So what I would do is I would write u here, same direction, same length, and then I would form v here. So this is u, this is v, that's the parallelogram. And then the resultant vector is going to be this one that goes from the middle to here. And it's pretty much up to you which one you want to use, but it still makes the resultant vector u plus v. So that's what's happening graphically. Numerically, it's pretty simple. What you're going to do is you're going to take the two vectors and then you're just going to add their components. So for instance, if I have u plus v, then what I'm going to do is I'm going to add the first component of u plus the first component of v, and that'll be the first component of u plus v, and then do the same thing here. So it's almost like we're finding the component form of a vector, almost, not quite, because it's plus, not minus. But that allows you to do it, the vector addition. So if we have the same points we had on the previous screen, if I just wanted to add u plus v, then that would be -1 plus 4 and 3 plus 7. And so to add the two vectors together would be 3, 10. And you can kind of see from the resultants there that they're going to be longer than each individual vector. Okay, a unit vector is going to have the same direction as a given vector. However, it's going to have this magnitude of 1, or 1 unit. Okay, and so a unit vector is going to be found by taking the vector and dividing it by its magnitude. So you would take the vector and its magnitude. So the first thing you have to do when you're looking for a unit vector is to actually find its magnitude. So to find its magnitude, we're going to use the distance formula. And so what we're going to do is we're going to take the first component and square it, plus the second part of the component and square it, and that finds the magnitude. And then we'll take that and we'll divide the actual vector by its magnitude, and that will get a unit vector. Okay, so we're going to find a unit vector in the direction of v, the vector v, which is the component 1, 2, and then verify that the magnitude is 1. All right, so the first thing we want to do here is we want to find its magnitude. So I'm going to find the magnitude of the component, which is going to be 1 squared plus 2 squared, which is going to be the square root of 5. Okay, so now we're going to write the unit vector, and the unit vector then would be 1 over the square root of 5, and then 2 over the square root of 5. So this would be the unit vector. And so now we want to verify. So to verify that its magnitude is 1, we're going to put it in the square root. So I will have this. And what I'm hoping is this equals 1. So that's what I need to verify. So I've got 1 over the square root of 5, and I've got 2 over the square root of 5. And if I square this, I'm going to have 1 squared over square root of 5 squared, which is just this, 1/5. And then I'm going to have 4 over this. This is going to be the square root of 5 over 5, which is the square root of 1, which is 1. So that is verified. So this right here is the unit vector, u, and then this is it verified. Now, another way to write a component form of a vector is to write it as a linear combination of unit vectors. So a linear combination, and let me write this down, to write it as a linear combination. So for instance, instead of writing it as, this is the component form, they write it in terms of I and j. So if component form is -2, 5, then -2i plus 5j is in linear combination form. And it's just another way of writing this. There's a reason behind it, but for now, I just want you to be aware that that's what that looks like. So if, for instance, they give you an example that says 3i minus 2j, and then find, it says u equals, find 3u. Well, what that means is, if I write this as a component, 3 negative 2, then 3u would be 3 times this. So 9 negative 6. And so it's just another way of writing it, and you can do the same vector operations whether it's written in linear combination form or if it's written in component form.